Welcome back to the London Futurist podcast. In this episode, we're delving into the fascinating topic of mind uploading. I suspect this idea is about to explode into public consciousness because Nick Bostrom has a new book out shortly called Deep Utopia, which addresses what happens if superintelligence arrives and everything goes well. It was Bostrom's last book, Superintelligence, that ignited the great robot freakout of 2015. Our guest this episode is Dr. Kenneth Hayworth, a senior scientist at the Howard Hughes Medical Institute's Janelia Farm Research Campus in Ashburn, Virginia. Janelia is probably America's leading research institution in the field of connectomics, the precise mapping of the neurons in the human brain. Kenneth is a co-inventor of a process for imaging neural circuits at the nanometre scale, and he's designed and built several automated machines to do it. He's currently researching ways to extend focused ion beam scanning electron microscopy imaging of brain tissue to encompass much larger volumes than are currently possible. And along with John Smart, Kenneth co-founded the Brain Preservation Foundation in 2010, a non-profit organization with the goal of promoting research in the field of whole brain preservation. So Kenneth, welcome to the London Futurist podcast.
Thank you for having me.
It's a pleasure to have you with us, Kenneth.
Kenneth, since you'll be our guide to some ideas which are going to stretch the imaginations of some of our listeners, what should we know about your background?
I think one thing that your listeners should know is that I kind of straddle the boundary between being very enthusiastic about the future, but actually very practical and skeptical at the same time. Let me straight away say, and I've said this many other places, that mind uploading is happening no time soon. We can dive into why that's the case. I see every day neuroscientists struggling to map a fruit fly brain and struggling to map even a cubic millimeter of tissue at a resolution that is good enough to get all the structural connectivity, but most likely not good enough to get what would be necessary to upload somebody. If I had to speculate, I would say we are at least 100 years away from routine uploading, maybe 100 years away from the first uploading attempt. And if there was an uploading attempt of a human being, it would be an Apollo moonshot scale project 50, 75, 100 years from now. Neuroscience has a long way to go. That doesn't mean, though, that I am dismissing it, obviously. I am enthusiastic. I think that that's what the neuroscience train is hurtling toward. It might be a slow train, but it is hurtling toward that. Everything that has been uncovered so far points to the idea that the mind is computational and that the computational level that the mind is written on is the level of neurons and synaptic connections between neurons and ion channels and receptor proteins that are allowing the electrophysiology of those neurons to do the computations. So at one step, I am saying something very mundane, that neuroscience is on track to understand the brain, but it's a very slow course. At the other, I guess I'm saying something very radical, something more radical than a lot of my neuroscience colleagues would like to say, that I think neuroscience will eventually be successful. And I think neuroscience is on the right track.
As you know, some futurists like to say that something may take 100 years, but we can do 100 years worth of work much more quickly than 100 years. And they justify that by saying we go through this exponential curve of progress. The example being the sequencing of the human genome. It was supposed to take 15 years. Halfway into that 15 years, very little progress had been made. But afterwards, it compounded and skills were able to be magnified. Bearing all that in mind, do you think there's any way that the slow train you envisioned might go through a similar acceleration curve?
I think so. And this gives me pause to make any type of predictions about the future. I'm putting this forward in the spirit of wanting to be very clear that I am not somebody that thinks that this is inevitable and very soon. That is the thing that pisses neuroscientists off the most. You wanted my background a little bit. There is one single thing that I want to accomplish that I am absolutely failing at. That one thing is to convince the neuroscience community, the large neuroscience community that is fantastically skillful at neuroscience. I want them to embrace the idea of brain preservation. I want them to work on methods that can preserve people's brains today in order to get to that mind uploading future. I think that that's very possible. That's why I started the Brain Preservation Foundation, put out a challenge prize, etc. One of the key blockages between the neuroscience community really throwing its expertise into this field of brain preservation that could save everybody. Let's just be very straightforward. The key thing that prevents the neuroscience community from doing that, one of the key things, is that this concept is associated with a bunch of fringe ideas that say that it's going to happen around the corner, that we understand the brain enough that in the next 10 years we're going to upload. That idea causes the neuroscientists out there that could develop brain preservation in a way that would save everybody. It causes them to run in the opposite direction and to, quite frankly, say stuff like, you can't preserve a brain, which is just completely wrong. This is why I'm trying to walk a very fine line. I'm talking to those neuroscientists out there that want to say, look, I got into neuroscience because I feel like neuroscience will be successful. I feel like the brain is computational. That's the whole allure of neuroscience, is understanding how the human mind actually works. And I want to be enthusiastic about that future, but I cannot countenance a radical misinterpretation of how close we are to that today.
I think it's very sensible to emphasize the enormous distance we have to go from a world in which a human or a chimpanzee can control some things going on in the real world by being linked to a computer through a few hundred or a few thousand connections from their neuron to a machine. And that looks very impressive when people can drink something from a cup just by thinking that they want to do that into a machine. But the distance between that and uploading, where all of our 86 billion neurons have to be intimately connected to or reinstantiated in a machine, is gigantic. In the normal run of things, as you say, it's hundreds of years or maybe thousands of years away. But as David said, exponential progress can make remarkable things happen much sooner than expected. People for a long time have shied away from Ray Kurzweil's prognostications. Oddly, it's looking increasingly like it's just possible he might be right in some of his timings. A lot of people who are at the cutting edge of AI are saying that we probably will get AGI or human-level AI by the end of this decade, which is what he's been predicting since the 80s. And then, of course, he says that there's been another 16 years to wait, and then in 2045, the superintelligence will enable us to upload. Actually, given exponential growth and given the enormous potential of a superintelligence, that's not utterly ridiculous, but it's certainly not something that mainstream scientists are going to want to be associated with right now. So I completely get your deliberate skepticism on that subject.
And I want to be clear, I'm not blind to the accelerated progress in AI that we've seen over the last couple of years. In fact, I would look at that and think that neuroscientists in particular should say, yeah, we told you, we've been telling you for the last 70 years that collections of neurons and ways of changing their synaptic connections with learning rules is a very, very powerful paradigm. So it is not unreasonable to speculate that we are looking at really exponential progress in things. It is also very possible that we'll see a stall, another stall, another stall. I look at the AI progress and I see a great lack of planned reasoning in, let's say, the large language models that are out there. There are certain things that they make drastic mistakes on that no agent that really understood stuff would make those mistakes. And so it's tantalizing progress, but there's another paradigm shift needing to happen, or maybe two, or maybe three. And being able to say that those will happen to get to true AGI, I don't think that can be given a timeline because these really are unknowns.
Yeah, fair enough. But we may not have reached the end of what scaling can do with large language models, and they do seem to do a basic form of reasoning. It's not as good as us, and we're not all that good at reasoning anyway. But it may need a new paradigm. It may need spiking neural networks or neuromorphic computing or something else. And we should probably spend most of this discussion on brain preservation because that's your primary mission. But before we get off uploading, I just want to ask you, because you've thought about uploading more than most, what's your attitude to the response to the uploading idea that you can't upload a mind? All you can do is destroy one mind and create a copy somewhere else. So in the sort of mandatory analogy, when Scotty beams Captain Kirk down to a planet, he doesn't transfer Kirk to the planet. He kills him on the Enterprise and creates a copy of him on the planet. Do you have a way around that objection?
I've argued it ad infinitum with people, including with Michael Shermer. He's probably the one that I've had the most back and forth with, him taking the opposite position. My take on this is that the concept that we have of a self is wrong. We have a folk psychological concept of self that is very, very, very flawed to begin with. Once you get rid of that folk psychological sense of self, then this becomes a non-issue.
So it doesn't really matter if you're killing him here and creating a copy. It preserves what's important.
There is no I. One of the things that I would suggest to listeners that might have this particular objection is if you were to frame the exact same objection, but for C-3PO.
This is a robot from Star Wars.
Yes, the robot from Star Wars. So you've got C-3PO and you've got a hard drive of C-3PO's mind. And you were saying, okay, we shut down C-3PO, we took out the hard drive, we put it into a different robot, we turned it back on. Is this the real C-3PO? If you made a copy of that hard drive, would it be the real C-3PO? Would you have two C-3POs? The answer to all of those that I think a normal person would give at some point would be there's no true answer. There's no further fact. That's what Derek Parfit, the philosopher, would say. There's no further fact to the question of whether this is the real C-3PO, whether C-3PO has survived this transition. And if we really take seriously neuroscience and biology, we are evolved machines that have consciousness based upon computations in the neural networks of the brain. If we really take seriously that idea, then there is no difference between what we would say about the robot example and what we would say about the human example. There's a red herring that keeps getting brought up that there would be a discontinuity of consciousness. This is ludicrous. We have discontinuities of consciousness all the time. That's what you pay for the anesthesiologist to give you a discontinuity of consciousness during a surgery. And you certainly don't think that you're a different person when you wake up.
Let's stick with that just a bit longer, because I'm sure in your many ad infinitum discussions, people have come back to you and said, okay, maybe they will be on the operating table, their brain will be copied, and they'll wake up on the operating table, and they'll see a robot walking around speaking as if they are them. And then they'll be asked, all right, do you mind now if we euthanize you because you're no longer needed? And if I was inside that biological body in the operating table, I would feel very queasy about saying, yeah, I don't mind being euthanized because I'm not quite the same consciousness as that guy over there who has a lot of my memories and seems to believe he is me, but I feel different. Can you just help me untangle that apprehension?
Yeah, I actually wrote a short story on this at one point. It was psychological advice for teletransporter users or something. First of all, if I was in that situation, if I woke up on an operating table and they said, the mind uploading procedure went perfectly well, there you are over there in that robot body. Go ahead and talk to Ken number 2 and see if you agree that all the pertinent things were transferred, and then we'll euthanize you. I would feel the same queasiness that anybody else would about saying, okay, yep, euthanize me. But I would be euthanized if the procedure went as well as it sounded, because that really is me over there. I can talk to me. It's the true me in every sense. And there's no reason to have two copies of me running around. And so I would be euthanized.
That really surprises me. That's counterintuitive to me, because I would have said, well, yes, I completely accept that's me over there, but I'm also me over here and I don't want to be killed. There's now two of me and we're going to branch and become two different people, but I care about my own survival as well as having some degree of care about Ken 2's survival.
Well, if you think about it from a planning point of view, let's say the transporters work this way on the Enterprise. And if Captain Kirk, every time he went down, was making a copy, and he's like, okay, well, I'm going to make a copy, but I'm not going to destroy the original, so I'm going to go on this away mission. But when I get beamed back up, of course, I'm going to leave a copy on the planet. That would become hilarious. From a practical point of view, usually you don't want a lot of copies running around. Let me give you a different analogy for a second. If I go in to get a vaccination shot, they roll up my sleeve, they have a big needle, and they're coming toward my arm. Clearly, there is a queasiness of sitting there while somebody is bringing this big needle toward your arm. You know it's going to hurt. There's an instinct in the back of your head that says, what the heck am I doing here? And yet, you know it's for your own good, and you sit through it. And you push aside that queasiness because we cognitively know what's going on. That is how people will feel about mind uploading at some point.
Interesting. I actually disagree with you. I think we'll want to have lots of copies of ourselves. And I think the revulsion or the dislike of the idea of having lots of copies, that's the thing that will go away. I don't see myself agreeing to be euthanized.
Okay. I don't disagree that we won't use copies and have mergers and all sorts of things. I think it will open up realms of human experience that we can't even fathom at this point. But I don't think we'll give in to our instincts that we can't push the off button because a successful copy has been made.
So I guess we're going to look at some slightly different situations now. Not when somebody is quite healthy and has woken up and is asked to be euthanized because there's a copy made. But on the contrary, somebody is dying. Somebody is on the point of death, and they may be asked to have their brain preserved. Other things they might do with their brain is give it over to some totally different kind of research, or just have it burnt in some religious ceremony. So in that stage, somebody's willingness to consent for their brain to be preserved is going to depend on their confidence that brains can indeed be preserved. And that's where the experiments that you have done and your colleagues have done, and for which prizes have been awarded, may change their minds. So could you talk us through the prizes that have already been awarded, not for the complete preservation of a whole human brain as I understand it, but for something at least partly along that route?
Yeah. So if we turn back the clock a little over 10 years, the cryonics community has been offering for decades and decades the possibility of preserving brains and bodies for long-term storage into the future, with the hope that eventually there will be future technology that can revive those people. The skeptical community and the mainstream scientific community, if you looked at, let's say 15 years ago, if you looked at the arguments that were written, they were arguments along the lines of, this does not work because it is destroying those structures in the brain that people know are important for encoding learning and memory. And so I looked at that situation, and other people that were around me looked at that situation. First of all, we talked to the chronicists and said, guys, why, if your technique is working, if it's working so well that you can actually offer it for money to people, then please publish a paper that shows that it preserves the synaptic connectivity of the brain, at least. And they had every excuse possible for saying that either that is not necessary, or look at these crappy images that we have, we're already there. And that wasn't convincing the world. And so into that, I said, we need a prize. We need a prize because there is a milestone, there is a goal that both the cryonics enthusiasts and the skeptics could agree on. The skeptics are saying, look, I don't think these people can preserve the synaptic connectivity of the brain. It's got ice crystal damage, it's got some other type of damage. I don't think it can be done. They could agree with that. And the cryonics would say, hell yeah, we can do that. Nobody has asked us. We just have never been asked, right? And so we formed the Brain Preservation Foundation. We got a donor that promised $100,000 to anybody that could demonstrate any technique that could preserve a large mammalian brain, in this case a pig brain, using a technique that could last in storage for over 100 years and demonstrate very precisely that throughout that entire brain, the synaptic connectivity of the brain was preserved. That was the Brain Preservation Prize. I thought that the cryonicists would easily win this. They did not. They still have not demonstrated that they can meet that criteria. There were other criteria, obviously. There was the criteria of publishing a paper in a peer-reviewed journal that showed this. That is also a very important thing. It's not just claiming that you can do it. Also, we had to witness the preservation. We had to do our own electron microscopy on it to show this. In any case, the cryonicists were not able to demonstrate that. I hope that they one day will. They keep saying that they're on the verge of it. We will see. But there were several other possible techniques involving aldehyde preservation that also had the possibility of achieving this.
Could you just explain what that is? What is aldehyde preservation?
Yes. You might say, okay, it's what people do for embalming bodies. I don't want to say that. That's essentially irrelevant because aldehyde preservation is what neuroscientists use when they want to study the nervous system at the finest levels possible. So if you want to map the connectivity of a mouse brain, the first thing that you do is you perfuse the mouse with a combination of paraformaldehyde and glutaraldehyde. What these aldehydes do is they kill the animal from a biological point of view, but they go in and they cross-link proteins together. That cross-linking of proteins almost instantly, like the first minute, they are cross-linking sufficient number of proteins that all the metabolism, all of the decay processes are 100% just stopped.
And sorry, what does that mean, cross-linking them?
Cross-linking means that the protein molecules have strong covalent bonds that are not going to unlink.
So it's freezing them in place, in a way. Not freezing, but fixing.
It's chemically locking them in place.
It's worth emphasizing the difference between freezing and this chemical.
That's true.
Because it's not cryopreservation, it's chemopreservation or plastination, I think I've heard the process described as.
It's aldehyde fixation.
The end brain doesn't need to be held at minus 180 degrees or anything like that. In principle, it could be held in your hand in room temperatures.
That's right. This is a technique that has been used at least since the 1950s to preserve the brain structure to look at under the electron microscope.
Yeah.
And it is used currently in just an enormous range of neuroscience techniques that not only study the synaptic connectivity of the brain at the nanometer scale, but also the molecular information.
Yeah.
There are techniques that people use nowadays that can actually look at the synaptic connectivity of the brain and also do immunostaining to look at any particular protein molecule in its context. I was reading a paper recently where they had an aldehyde fixed brain that they had expanded. They had stained all the proteins so that you could see the synaptic connectivity, and they could look in fluorescence at individual ion channels that had been immunolabeled.
So to bubble it up to the superficial level I like to live at, as I understand it, a company called 21st Century Medicine successfully did this operation with a small mammal in 2010 and then a large mammal in 2016.
Yeah.
One of the things that fascinates me is how did you know that they'd been successful? How can you tell that the brain has been preserved in potentially working order?
Let me be very clear on what they did. The technique of aldehyde fixation has, again, been used for decades and decades and decades, since at least the 1950s. That technique preserves the brain very well, but not necessarily for hundreds of years, because it is still in a fluid bath. The proteins are cross-linked, and for months it's stable. But for years and decades and centuries, that had never been shown. And that's still an ongoing research project to actually say how much decay under what fixation conditions. There's a bunch of people that are trying to do room temperature storage. But what this 21st century medicine team did was they combined that aldehyde fixation with cryopreservation. So they developed a technique where they could perfuse with aldehyde fixative to fix the proteins in place, and then perfuse with a cryoprotectant agent that would allow that brain to be lowered in temperature to minus 130 degrees Celsius and vitrified as a glassy solid. No ice crystals, but vitrified as a glassy solid.
Yeah.
It could stay that way for centuries without issue. How we evaluated that was that we saw that brain vitrified, solid, took that out, rewarmed it, sliced it into pieces, and then took those pieces and did electron microscopy on those pieces of brain that had been in minus 130 degrees long-term storage. Those images looked like they hadn't undergone the low temperature procedure. You could still see all the synapses, you could still trace them.
You could do before and after comparisons, and the structure was as it had been before.
Exactly.
Cool. So, David, if I can ask you a question, because I know that, like me, you're a cryocrastinator. Do you look forward to the day, hopefully fairly soon, where aldehyde fixing followed by cryopreservation is possible? Would you sign up for that?
Well, I'm still in two minds, dare I say it. I may end up in two minds, as we've just been talking about. I think there's a possibility that the traditional cryopreservation route may preserve enough structure in the brain, and that's what I wanted to ask Kenneth about, because I understand that people from Alcor and other companies say there is evidence from MRI scans that sufficient brain structure is retained. How do you evaluate that response, Kenneth?
I'm not sure about MRI. They also use CT scans. MRI and CT scans don't show anything. I mean, they show if the cryoprotectant possibly gets into different regions, they would show macroscopic damage. There was a reason why the Brain Preservation Prize required ultrastructure images, electron microscopy images. The human mind is written in synaptic connections. You need to show that those synaptic connections are being preserved. I don't know if the current cryonics procedures preserve those or don't preserve them. And that is what's most frustrating. How can it be? How can it be that the cryonics community has not flooded the scientific literature with proof in the form of electron microscopy or whatever other microscopy that the human patients that they've been preserving for decades have been preserved well enough to preserve the synaptic connectivity of the brain? How can that go on? Why are the cryonicists that are signed up for these companies, why aren't they beating down the door asking for that evidence? I was signed up with Alcor. I was enthusiastically expecting them to win our prize and finally show the skeptics that they've been wrong all these years. And what ended up was that they failed to meet our prize, and I publicly ripped up my Alcor membership because they couldn't show that they preserve the brain.
So, Kenneth, what's your current strategy? Are you working on an alternative approach which involves aldehyde as well as cryopreservation? Or are you just kind of waiting for the cryonicists to take up your recommendations?
My current strategy is I'm probably going to die like everybody else. But I'm going to die with this understanding that it didn't have to happen, because there are plenty of people in the neuroscience and medical community that could make quality brain preservation happen essentially overnight.
Wow.
It is that close. And yet, so this is really a sociological problem. If there's neuroscientists out there listening, if there's medical doctors out there listening, if you don't buy the idea that we're computational, that what we really need to do is preserve the computational aspects of the brain so that you can undergo future uploading, hey, that's fine. But realize that that's counter to the neuroscience textbooks, just straightforward. If you don't buy that, that's fine. But if you do buy all of that, then please realize that you are preserving animal brains in your experiments and measuring the molecular changes that synapses undergone during learning and things like that. You know that brains can be preserved in animals extremely well. That same thing could be applied to human beings.
That's a very powerful argument, and you're very passionate about this. Deciding to die isn't really a strategy. You are an entrepreneur. Why don't you set up an alternative to alcohol, which does involve aldehyde preservation as well?
I'm not an entrepreneur. I'm anything but an entrepreneur. But the team that won the Brain Preservation Prize, they have a research company that is trying to push forward a technique that will eventually be offered to human beings. There's at least one other high-quality research lab that is really pushing aldehyde fixation as a brain preservation technique. They are going about it in ways that I think are very principled. You need to demonstrate things working in the open, peer-reviewed science and medical journals before you offer them to people. So there are people that are doing that. I hope that they succeed. What I also feel, though, is that it's not an easy task. Let me give you an analogy. It's kind of like we have successful open heart surgery because the medical and scientific community embraced the possibility that that was the case. And a lot of people came together and just made it happen. And they're really, really the highest professional people with the best funding in an open environment made it happen. And that's why we have open heart surgery.
Yeah.
If we had a default ban on even discussing open heart surgery, and you had some back alley open heart surgeons that really were quite enthusiastic about it and had a good veterinary background or something like that, I would feel like, no, I ain't getting open heart surgery.
Yeah.
And I think that's where we are.
So let's talk timescales again. This time not timescales to when mind uploading may be possible, but timescales until we have a company that can realistically offer this preservation aspect. So what by default do you expect? How long will it take, and how long might it take in a better circumstance when people were able to discuss this more open in a better sociological context?
There will be something offered, I suspect, relatively soon. You should understand the role that the Brain Preservation Foundation plays at this point. The role that the Brain Preservation Foundation plays, it's a medical advocacy group. It's saying, hey, we should be developing brain preservation. That's our main role. We are also skeptical in the sense that we want to see the evidence. That is our mantra. We need to see the evidence that these things work. That's what the main goal of the Brain Preservation Foundation is. It's not to develop one of these techniques. We're not embedded. We have essentially a firewall between us and any of these providers, including the cryonics providers. We have to have enough of a distance between them so that when they say that they have a technique, we can say, prove it, and have some credibility so that when we say, yes, you achieved it, people will trust us. And if we say, no, those images looked crappy, you need to go back to the drawing board, that people will also say, oh, yeah, it's that type of credibility. So I can't give a timeline because I'm not embedded in these companies.
I'm surprised because 8 years ago, somebody convinced you that they had successfully preserved a pig's brain.
Yeah.
Now, pigs and humans, that's a long way apart, but we're just bigger scale, more neurons, more folds in our prefrontal cortex, etc. And with the sort of galloping speed that AI tools give us, I would have thought you'd be saying it would be possible in, say, 10 years if we spent enough money on it, something like that.
Absolutely, and much less. So let's look at that pig brain. That pig was, like all of these laboratory animals, perfused with aldehyde fixative while it was living. That means that the vascular access was essentially perfect. If that was done on a human being, it would result in the same quality. So there is a technique that if you took a relatively healthy human being and put them under anesthesia and then perfused with aldehyde fixatives, that would be equivalent to what was done in the pig. I don't think there's any neuroscientist that would doubt that that would work. Well, maybe there would, but there's no principled reason to suspect that that wouldn't work because it already works on pig brains, it works on mouse brains, people do it all the time. And so there is this question of, can this be done in a not so dramatic effect? Because legally, for some reason, I don't think that this is a good law. I think that if somebody is a terminal patient already, that they should be able to get the best preservation that they can. If I was the Supreme Court, that's what I would judge. I would say people have the right to choose to preserve themselves under the best conditions. If that means that they undergo a euthanasia procedure 6 months before they would die naturally because they want their vascular system to be in the best case for this procedure, who are we to say that they can't? Because this is literally a life or death situation for them.
I quite agree with this. The people who go to Dignitas because they're either suffering or about to suffer intolerable pain for the rest of their lives, and they go to Dignitas to stop that, why on earth wouldn't you say to them, by the way, we can preserve your brain and maybe in a couple of 100 years, somebody will bring you back? That seems like a pretty obvious and reasonable thing to offer.
So I agree with this completely. I wish we lived in a world that believed in science and the future enough to make that happen. Apparently, we don't. The two examples that I'm thinking of, I'm not going to name the examples, but the two examples of companies that are looking into this aldehyde fixation, they have essentially decided that they're not pursuing that best possible course because of the legal headaches that would be involved. The moral outrage, the people with pitchforks and torches would come to their door and say, we need to shut this place down. Let's be honest. If you were going to people that were thinking about euthanasia and saying, hey, you should really do euthanasia because you're going to be uploaded in the future, the vast majority of humanity, wrongfully, would think that you're morally reprehensible killers.
But that's why I'm suggesting doing it the other way around, going to people who are already going to be euthanized and say, as an add-on to your euthanasia, do you want us to store your brain?
I'm saying even under that circumstance, it is fraught with moral hazard, as they would say. In any case, I think that there's happy mediums here, and a lot of these people are pursuing those happy mediums. There are the Alcor technique, or the cryonics technique of basically saying, we're only doing this to dead bodies. We get called in when somebody is dead, not after euthanasia or anything like that, but we get called when the doctors have said they're dead. That is the easiest path. It is not clear that that produces as good results. People are stuck in that kind of research right now, from what I've seen. Can we work around the legal headaches to get a technique that works as well as it did on the pig, but doesn't bump up against these legal issues?
So the last question for me may be the hardest of all, because Kenneth, you talked about the world's not in a state today when it believes in science. Is there any hope that the world will become more open to scientific considerations, less swayed by these, let's say, non-scientific or anti-scientific prejudices?
I feel that if you zoom out, the world has always been progressing in the right direction. These are momentary blips. I feel very sad sometimes when there's neuroscientists that publicly embrace what a few decades ago would be considered nonsense fringe stuff. I'm thinking about integrated information theory of consciousness and panpsychism and stuff like that. They've made some serious inroads into the neuroscience community. But I feel like the core of science is progressing, and we're not going to slide back on that. I'm very optimistic. If we're talking about whether I get there, who knows? The world goes through a lot of upheavals and progress is not steady. Right now, the environment is not great for brain preservation. If this generation bites the dust again, there's so many things in the world that could be solved that aren't getting solved for sociological issues. This is just one of those. But over the long arc of history, I think we're going to get to mind uploading. We're going to get to a great future, and I'm confident in that.
Well, Kenneth, you're a young man. I think you should be more optimistic that it can happen in time for you to take advantage of it. I think you should hop on a plane and go and see the Crown Prince of Saudi Arabia, because he has said that he plans to live pretty much forever, and he's got the resources to make this kind of thing happen. It sounds doable to me.
I am a low-level researcher. I'm a low-level researcher that solders resistors on a daily basis.
Yeah. No, I'm sure that's not false modesty, but I think it is too immodest. And by the way, when I said you were an entrepreneur earlier, I hope you realize that was actually a compliment.
Thank you.
With that compliment, I guess we really have taken up too much of your time. This has been a really, really interesting conversation. I think terribly important. And thank you very much for joining us.
Thank you.
Thank you, Kenneth. And to any of our listeners who have a different opinion about some of the topics mentioned, please get in touch and we can continue this conversation in future episodes. Thank you.
Thanks, Ken.
Bye-bye.